Well, hi everybody. All right, we'll work on this practice test, and we're going to solve equations on this page. And this is a cube root. So we want to get rid of the radical. So we're going to raise a third power, and the cube root of 3 are going to cancel each other out. And then we also have to raise this to the third power. So the cube root and the third power leaves us with just the x minus 2. And then 3 to the third power, that's 3 times 3 times 3, that is 27. So I will add 2 to both sides, and I have x is 29. And then I'm going to check. And the cube root of 29 minus 2, does that equal 3? That's the cube root of 27. Does that equal 3? Now you either put it on your calculator, or I do know that 27 is 3 to the third power. I already talked about that over here, didn't we? And the cube root and 3, that does cancel out. So 3 does equal 3. X is 29 there. The second example, I'm going to subtract 4 from both sides. And I've got the square root of x plus 2 is equal to 3. Now this is a square root, which means squaring is what I do to put the inverse operation, so that will cancel out, and that leaves me with x plus 2. 3 to the second power is 9. I'm going to subtract 2 from both sides, and I got x equals 7. And I'll check this one over here. And the square root of 7, and for x, plus 2, went a little far on that radical. The plus 4 is not under the radical, is equal to 7. And that's the square root of 9. I'll put a question mark over that. Plus 4, does that equal 7? That's 3 plus 4 is 7. 7 does equal 7. All right. So x equals 7. That checks out. Now this one, you got square roots on both sides. This has a square root by itself, so I'm going to raise that to the second power. I'm going to raise that to the second power. That whole thing. Square root and square cancel out, and I have x minus 12. And then I'm going to just expand this like so. Instead of 2 minus square root of x to the second power, I'm going to go 2 minus the square root of x times 2 minus the square root of x. And then this is x minus 12 here. I'm going to FOIL. 2 times 2 is 4. 2 times negative radical x, that's negative 2 radical x. Negative radical x times 2, that is also negative 2 radical x. And then the negative square root of x times the negative square root of x, and negative times negative is positive. Just as kind of a review, x times x, that's x squared. So square root of x times square root of x is square root of x squared, and the square and square root cancel out, and that is just plain old x. Let me simplify that a little bit, because I can combine these two terms. So that brings us 4, negative 2 minus 2, that's negative 4 radical x, and then the plus x. Now I'm going to solve for this square root of x, because we still have the radical. We got rid of this radical, but we still have a radical. So I'm going to subtract x from both sides. That cancels. So I have negative 12 equals 4 minus 4 radical x. And then I'll subtract 4, and I am looking at negative 16, equaling, that cancels, negative 4 radical x. I'll divide by negative 4, and it looks to me like negative 16 divided by negative 4 is 4. Those cancel. That equals the square root of x. And now I'm going to square both sides. So I have 16 is equal to x. And it is time to check this. I'm going to check it on another piece of paper real quick here. So I had the square root of 16 minus 12. Put that in for x. Does that equal 2 minus the square root of 16? Right? Yes. So that's the square root of 4. Does that equal 2 minus the square root of 16 is 4. This is 2. This is negative 2. Those are not equal. Okay? So this doesn't work, and we have no solution. All right. This one, I'm going to add 1 to both sides. I've got 6 equals the square root of x minus 2. So just to go back here, it is important to check. You can see that checking does need to happen. So let's raise to the second power. We have 36, and that's equal to x minus 2. I'm going to add 2 to both sides. I have 38 equaling x. Now let's check. Does 5 equal the square root of 38 minus 2 minus 1? Does 5 equal the square root of 36 minus 1? Does 5 equal 6 minus 1? Yes, it does. 5 equals 5. All right, we're good, and we've checked it. Let's try this one. This is similar in nature to that one, so let's square both sides. All right, that is x plus 15, because the square root and square cancel out. And I'm going to expand that again. 5 plus radical x times 5 plus radical x. I'll write that down. And then 5 times 5 is 25. Outside, 5 times radical x is 5 radical x. Inside, 5 times radical x is 5 radical x. And last, square root of x times square root of x is still x. This one had a negative times negative, but that's still positive x. This is positive times positive. That's positive x. So x plus 15 equals 2. 5 radical x plus 5 radical x is 10 radical x plus x. I'm subtracting x from both sides. I got 15 equals 2 plus 10 radical x. I'm going to subtract 2 from both sides. I got 13 equals 10 radical x. And I'll divide both sides by 10 here. And 13 divided by 10 is 1.3. I'll come over here. That's 1.3 equals the square root of x. And then I'm going to square both sides. And if you take 1.3 squared, you're going to get 1.69. I'll get the calculator. One 0.3 to the second power is 1.69. 1.69 is equal to x. All right, time to check 1.69 in this one. The square root of 1.69 plus 15, does that equal 5 plus the square root of 1.69? Okay, that's the square root of 16.69. So let's do that. The square root of 16.69, I'm getting 4.0853. Does that equal 5 plus and square root of 1.69, this is not equaling, and I'm going to have to go back. I'm going to check, because I might have missed something here. 5 plus 1.3, that's 6.3. Those aren't equal. Let's look at the work one more time. Okay, I see the problem. How many of you caught that 5 times 5 is not equal to 2? 5 times 5 is 25. Okay? So if it doesn't work, first thing I'm going to do is go back and look at the problem. I got 25 there. Oh, lessons to learn here, huh? I got 25 here, so I'm going to subtract 25, subtract 25. 15 minus 25 is negative 10. Okay. 15 minus 20. So negative 10 divided by 10 is negative 1. And that's equal to the square root of x. And then when I square that, I got 1 is equal to x. Well, let's check 1 now. Okay, so the square root of 1 plus 15, is that going to equal 5 plus the square root of 1? And that's the square root of 16. 5 plus 1, that's 4, and that is 6. And they are still not equal. So x, I got equals 1. This is extraneous. So I'm going to go with no solution on this one as well. A little room there. All right, number 6. I want to add 4 to both sides. I've got 2 times 6x minus 3 to the 1/3 power is equal to 4. And then I'm going to divide by 2. So I'm going to get this parentheses part by itself before I start raising powers here. 6x minus 3 to the 1/3 power is equal to 2. And I think we've been in the habit of just changing that. A 1/3 power is a cube root. Cube root of 6x minus 3 is equal to 2. And then we are pretty familiar. That's putting that to the 3rd power. So I have 6x minus 3 is equal to 8. And I add 3 here, and I add 3 here. And I've got 6x equals 11. Write that up here. 6x equals 11. I'll divide by 6. I'm going to leave that as x equals 11/6. And then I'm going to check it. And I'm going to check it totally in the calculator, and I'll show that. So here's my check. 2 times 6 times 11/6 minus 3 to the power of, I'll write that out, 1/3 minus 4. I want to see if we get 0 when we do this. Okay, let me show the calculator as much as possible here, and I'm doing this right here. 2 paren 6 times 11 divided by 6 minus 3 theses to the power of 1 divided by 3. Now to get out of the exponent, I'm going to hit this arrow. I'm going to subtract 4 from that. If I get 0, I'm going to say 11/6 is my answer. And I do get 0. Right there. So x does equal 11/6. It does check out. All right. Number 7. I got the square root of 2x minus 7 equals the square root of x plus 2. If I square this side, I've got to square this side, and that gets rid of both radicals. So 2x minus 7 equals x plus 2. Let me get the variables together. 2x minus x is x minus 7. Bring that down. That canceled, equals 2. Add 7. Add 7. I've got x equaling 9. And 2 times 9, so I'm checking now. 2 times 9 minus 7, is that going to equal the square root of 9 plus 2? 18 minus 7 is 11. 9 plus 2 is 11. Yeah, that checks. X does equal 9. Number 8, cube root of x plus 8 minus 6 equals negative 3. Let's get the cube root by itself first. So I'm going to add 6 to get that to cancel. Cube root of x plus 8, negative 3 plus 6 is 3. All right, cube root. I need a third power here, third power here. Those cancel. I've got x plus 8 equals 27. I'll subtract 8, and I'll subtract 8. I've got x equals 19. Now let's check. Cube root of 19 plus 8 minus 6 equals negative 3. Cube root of 27 minus 6 equals negative 3. Okay. Cube root of 27. I've done that several times. 27 is 3 to the third. Or you could put that in your calculator. We're wondering if that's the case here, right? Cube root and third power cancel out. So that's 3 minus 6 equals negative 3. Negative 3 does equal negative 3. All right. 19 is the correct answer there. This one, let me add 1 to both sides and get the parentheses by itself. So 4x minus 1 to the 1/5 power is equal to 3. All right. And I'm going to write, instead of 1/5, I'm going to write the 5th root of 4x minus 1 equals 3. And I will take that to the 5th power. So 4x minus 1 equals 3 to the power of 5, 243. Let's add 1 to both sides. I got 4x equals 244. And I'll divide by 4 here and here. And x equals 61. X equals 61. So, checking. I'm going to take 4 times 61 minus 1 to the power of 1/5, and then subtract 1, and then I'm wondering if I'll get 2 when we're done. I'm going to do that totally in the calculator. Paren 4 times 61 minus 1 theses to the power of, come on, focus. Okay. To the power of 1 divided by 5. Hit the right arrow to get down out of the exponent. And then I'm going to subtract 1. And I get 2. I got that answer. All right, it checked on our calculator. When you do show the check, show what you're putting in the calculator like this, and then, because I'm going to require that you check all these. So, number 10, the formula T equals 2 pi times the square root of L over 32 represents the swing of a pendulum, where T represents the time in seconds to swing back and forth, and L is the length of the pendulum in feet. So we got feet, And we got seconds as our units here. How long is the pendulum? So we want to know L. At cosi, if it takes 6.89 seconds to swing back and forth. 6.89 seconds. That is time. That's going in for t. Then I got 2 times pi times the square root of L over 32. I'm going to do something here real quick. I'm going to take 2 times 3.14, and I get 6.28. So 6.89 equals 6.28 times the square root of L over 32. I'm going to divide by 6.28 here and 6.28 here. 6.89 divided by 6.28, 1.097. I'm going to go 1.097. I'm going to round that a little further. Equals square root of L over 32. I want to get rid of the square root, so I'm going to raise this to the second power, and I'm going to raise this to the second power. So 1.097 to the second power. Oh, I have an X squared button. 1.2034. 1.2034. These are approximations, right? Square root and square cancel out. That's L over 32. And now I'm going to multiply this side by 32, and I'll multiply this by 32. So 32 times 1.2034. I'm going to go with 38.5 feet. Okay. Now I'm just going to check real quick. I want to see what 38.5 will do in this equation. 2 times pi. There's a pi button here. I think I'll actually use it this time, if I remember where it is. There it is. Second, and then it's this button right here. 2 times pi times the square root of L's 38.5. 38.5 divided by 32. .89, very close, 6.89 there. All right, so at cosi, that pendulum, if you've ever been in there, about 38.5 feet long. All right, guys, this is a summary of the test here.